Writing direct variation equations. In the previous sections, we talked about the constant of variation. The thing that's being multiplied by x, it forms a proportional relationship because we're always starting at 0, 0. Now, already kind of touched on in the previous section how to write a direct variation equation, but let's go ahead and take a look. So we know that whenever we're given information and perhaps given an x and y coordinate, then what we're able to do is substitute that in for the formula of constant of variation, which is going to be y equals kx. We're able to do that and then start solving for pieces. So you can see here there are two separate problems set up. We can find the information that's given to us, our y, our x. We're using y equals kx and substituting variables in, and then solving for k. Once we solve for k, we might need to find out what another output would be or another input would be based on the constant of variation we find. Let's take a look at some examples. So always starting off with y equals kx. And we know that we're given y and x is 10. All right, so for y, I'm going to substitute 20. I don't know k, but I do know that x is 10, so 10k. So this is a one-step equation. Should be very familiar with this. I'm going to divide both sides by 10. K equals 2. So whenever we're going to write the equation that these two coordinates were made from, it would be y equals 2x. We found out k was 2, so we wrote the equation that would generate those coordinates. Over here, you can see something very similar. We're going y equals kx. And then we have y is 6 and x is 3. So I'm going to substitute 6 in for y. 6 equals x is 3, so 3k. Same thing, one-step equation. Divide by 3. K equals 2. Now I'm able to rewrite the y equals kx with k substituted in. And that's going to be the equation that we can substitute input values to generate output values. Y equals 2x. A step that could come after this is what would y be if x was 6? And we know that it's constant proportionality, a constant variation. So we'd be able to plug that in for the x value and generate the y value. And this is where the equation evaluating all comes back into play. So generating an equation to evaluate.